Hello and welcome, students. We today we are going to talk about the trigonometric uh, applications. So this is the ninth chapter. This is the extension of the chapter 8 trigonometry, which we have studied. So here in this particular chapter, we are going to learn some of the applications related to trigonometry. So it would require some of the things which we have learned in our eighth chapter. So let's recall it. Okay, some of the things which would be required is one of this rhyme which we know, which we have used, the perpendicular base, perpendicular, hypotenuse base. So this rhyme we know, right? So this is related to perpendicular, by hypotenuse is related to sine, for the sine. Okay, and this is related to the cos, and this is related to the tan. So this I hope we remember from our previous session in the chapter trigonometry. So this would be required. So as I've said, multiple ways are there to remember this. So instead of that, what I would say is try to practice this, writing this PBP under HHB. So this is how, if you write it, practice it, you will be able to remember this. So this can help you with respect to the remembering of the trigonometric ratios. So once you know sine, cos, tan, you can find cot, which is reverse of tan, then cos, then which is reverse of secant, then sine, which is reverse of the cosec. Okay, so hope we remember this particular ratios in a previous chapter, from the previous chapter. If not, please have a look, practice it. It's simple enough. Okay, so it will help you out in solving anything which is related to this trigonometry. Okay, so having said that, let's move to our next slide. For the next concept which we need to remember is the trigonometric values. So we have derived in our previous session with respect to the trigonometric chapter, the 0 degree, 38 degree, 45 degree, 60 degree, 90 degree. So in this particular application, we would be utilizing, you don't need to remember all. We have seen the way to retrieve it, the values. If not, you can by heart this, if you know 3 for sine, cos, tan, you will be able to utilize it for the programs which we will be doing, the upcoming examples. Okay, in that we'll see how we can do. So it's requires only the practice, so that way you will be able to remember this values, trigonometric values. So mostly we'll be utilizing the values which are here. Okay, let me just change the color here. So if you see this area which would be required, okay, so you need to remember this. Mostly this is the one which we'll be using in our examples. Okay, so in this particular session we'll do certain examples to understand more clearly related to this chapter, so which are important. Okay, so sine theta, sine 30 means half, sine 45 is 1 by root 2, sine 60 is root 3 by 2. So this is what we have seen mostly. So it's better to remember this table. Okay, and how do we remember? We have the either we can do derive it, or we can just remember it by practicing, so that we write it down whenever in the exam. We write it down this table and it's easy to recall it. Okay, hope this first thing is the ratios need to remember, then the values of this trigonometrics. Okay, angles. So these are the two things which will be helpful in the application related to solving the trigonometrics. Okay, applications which are related to trigonometry. So then there is a new concept which we need to know. Okay, which is straightforward, simple enough. So there are four terms which I have written, so just it will be referred in our examples and the questions related to the applications of trigonometry. So for example, here you have a view. Okay, you have a view. Okay, there is a person, okay, who's sitting down, and okay, and you have a kite. Okay, you have a kite, kite at the sky. Okay, kite, you have it at the top. So this way, if from down, if you look it, okay, from down if you look it, so this view, this sight, when you're seeing this kite, this is called line of sight. Okay, line of sight. Let me change the color here. So from from the view you are seeing this kite. So this is called line of sight. Okay, and the horizontally, if you see, there is one straight line which goes. Okay, so from your eye perspective, the horizontal line which you draw, that is called the horizontal line. So simple enough terms. Okay, so don't get complicated. In simple terms, you just remember. So the line of sight is nothing but the sight here which you are viewing. Okay, so if you form a line here from your view to the sight, so that becomes a line of sight, as the name says, line of sight. Okay, and the straight line from your view, horizontal line, okay, that forms the horizontal line. Okay, this we'll see why we require this. Okay, you know what is line of sight and what is horizontal line. Okay, similarly, if you look at down, okay, so you are standing here. Okay, you are at some place at the top. Okay, so you are assume at the bridge. Okay, then from there, if you're looking down, if you're looking down the river, okay, the boat, okay, you say there is a boat. Okay, there is a boat. So from here, from the top, if you're looking down, this also is nothing but the you have your sight seeing here. So this from your eye to this is called line of sight. Okay, so either you can see at the top or you can see at the down, line of sight. Okay, and the line which is drawn here, okay, it's nothing but the horizontal line. Okay, horizontal line. Same thing here, horizontal line. So I hope these two terms which we are talking about is clear, right? From the side, if you're looking at the top, okay, and you form a line, so it's a line of sight. Similarly, if you are at the top, okay, say assume you're at the mountain and you're looking at down, which in the river, and there is a boat. So then this becomes the line of sight, and the straight line which you draw with your eye contact, it's called nothing but the horizontal line, as the name says, horizontal. So horizontal it will be. Okay, so this is there. So as I've said, if angle of elevation, so if you see at the top, elevated. Okay, so angle of elevation, this is called, it forms an angle. So this is nothing but the angle of elevation. If you see at the down, then it forms another angle which we call it as angle of depression. So in simple terms, if you see at the top, elevated, elevation angle, and any angle which is being formed from top to down, it's called depression. Okay, so we need to know what is line of sight. Line of sight is from the place where you're seeing the object. Okay, that is called line of sight. Okay, and from your eye view to the straight line, if you form, that is horizontal. An angle of elevation, it forms an angle. If it viewing at the top, it's elevated, it's angle of elevation. If you're looking at down, it's the depression. So you can remember, elevation is nothing but the at the top, depression is nothing but the down. Angle of elevation, angle of depression, these are the terms which we'll be using in our examples when we are solving the questions. Hope this is clear, students. So just terms, these are just no need to buy art. So just when this in being referred, so just try to recall that. Okay, that's all. So it will help you to draw the angles. Okay, so let's move to our examples. One hope we are clear with this particular topics here. Okay, let's move to our examples. Okay, so let's read our question here. A tower stands vertically on the ground, okay, from a point on the ground which is 15 meter away from the foot of the tower. The angle of elevation of the top of the tower is found to be 60 degrees. Find the height of the tower. Okay, so there is a tower. So tower is nothing but it is standing vertically. Vertically means it is standing like this. Let's take a line. Okay, so you have a vertical tower. Okay, say the tower of what you can say, the telecom tower or whatever the tower you want to consider. Okay, so it is standing vertically. Vertically is standing. The tower stands vertically on the ground. So drawing a figure is very important. It will help you to analyze the problems what is being asked, the question, transforming the question. Okay, so we have done stands vertically on the ground from a point on the ground, okay, which is 15 meter away from the foot of the tower. Okay, okay, so it says that so this is the foot of the tower. Okay, there is a 15 meter away from the foot, the angle of the elevation. Okay, so it says from a point on the ground which is 15 meter away. Okay, so from this point, okay, point on the ground, okay, which is 15 meter away. So you have a 15 meter away, okay, away. So away means this side. From the point away we are going, okay, foot of the tower. So from the foot of the tower, the angle of elevation of the top of the tower is found to be 60 degrees. So elevation, when I said, as we have discussed, elevation is nothing but elevate at the top. Okay, so the angle, if you look it, sorry, so if you look it from here to the top, it forms an angle. Okay, so it forms an angle. So this angle is nothing but 60 degree. Okay, so it's saying that it's forming an angle of 60 degree, and we have seen it is the distance, this one is given as 15 meter. Okay, so this distance is known 15 meter. Okay, what else is given? Find the height of the tower. So they're asking the height of the tower. Find the height of the tower. Okay, this is what we need to find. Height of the tower. So have we converted the question with all the information data provided? Yes. Tower stands vertically. Find from a point on the ground which is 15 meter away from the foot of the tower the angle of elevation. So angle of elevation. Elevation, always remember, elevated at the top you have to see. Okay, so top you have see 60 degree angle of the top of the tower is found to be 60 degree. Find the height of the tower. Okay, so we have got the information required from this. So we need to find the height. Okay. Okay, so let's name it as A, B, C. Okay, so how do you find it? So what it is asking, so the height is it is asking. So degree is given. Okay, so using this, what we can do is, yeah. So the height is being asked to 60 degrees. So what is this? This is perpendicular, this is perpendicular, and this is the base. Okay, this is the base. So this is nothing but we have perpendicular by base. So what is this? This is nothing but tan. Okay. So tan theta. So tan theta, it is as tan. So tan theta here. And what do we need to find? Tan theta is nothing but you have a 60 degree perpendicular. Opposite to that is the perpendicular. So opposite to this 60 degree is AB. So AB, then base. What is base? Base is BC. Okay. We have a 60 degree angle given. So we can put the angle as tan 60 degree is equal to AB. What is AB? AB is, we need to find height H, BC. BC is nothing but 15. Okay, so 15. And we know what is tan 60 from our table, students. Tan 60 forms you root 3. Okay, from the table, trigonometric table. So which we've discussed in a uh, at the start of the session. Okay, so tan 60 is root 3 H divided by 15. So this becomes 15 root 3 H. So this is what we were supposed to retrieve. So the value is, the height of the tower is 15 root 3. Okay, so you can leave it here. Further, if you want to simplify, if the root 3 value is given, you can simplify, or you can leave it here as well. Instead of simplifying root 3, we can keep the value as h is equal to root 3, or you can write something like height of the tower is h. is equal to 15 root 3. Okay. Okay, students, that's what we can write it down this one. Okay, so we what did we do? Since first thing is from the question we drew the diagram. Okay, so the angle we found and we drew the information whatever is provided, and we found that height need to be found. So by there are multiple ways. So here one way was since height need to be found and degree is given. So when degree is given, so what we utilize is we utilize the trigonometric ratios. Okay, and found the value by one unknown was there. So we found the value by substituting the since it forms the it is asking you the perpendicular by base, and we know perpendicular by base is nothing but a tan. So then we replace the tan value by replacing and substituting the value, we got the value of h. So if it was supposed to ask this, okay, so then there was one more way. So finding the sides, okay, the sides length of the sides, okay, we use the Pythagoras theorem. So here we don't need, only the height was being asked and two information was provided, so third information we found it. So this is one way. Hope this is clear, student. Okay, so let's move to our next question. An electrician has to repair an electric fault on a pole of height 5 meter. She needs to reach a point 1.3 below the top of the pole to undertake the repair work. Okay, so there is an electric pole where it need to be repaired. Okay, and it is 1.3. Let's come back. What should be the length of the ladder that she should use, which, when inclined at an angle of 60-degree to the horizontal, okay, so horizontal would enable her to reach the required position? Also, how far the foot of the pole should she place the foot of the ladder? Okay, so first thing it says that there is an electric pole. Okay, so let's do an electric pole. So there is an electric pole here. Okay, so let's draw from the diagram. Okay, we have an electric pole of 5 meter. Okay, so let's draw an electric pole of 5 meters. So you have an electric pole of 5 meter. Okay, fine. She needs to reach a point 1.3 below the top of the pole. Okay, so this is the top of the pole. Okay, top of the pole. Then she needs 1.3. Okay, so 1.3. I assume this is 1.3. Oops. So this is 1.3. Oh, okay. So this is 1.3. Okay, so we know total it is 5 meters. Okay, so 1.3 down. Okay, so from there below the top of the pole to undertake the repair work. So here the electric pole meter is there, so we need to take. Okay, so we need to go down here 1.3 meters from the pole, repair work. So repair work need to be done here. What should be the length of the ladder that she should use, which when inclined at an angle of 60-degree to the horizontal? Okay, so inclined at an angle of 60-degree to the horizontal. Okay, so horizontal. So pole is here. Okay, so pole is here. So here it says that 60-degree horizontal. So horizontal is this one. Okay, this is horizontal. Okay, so horizontal line from this side. So from here it is looking. Okay, from horizontal line. So it says 60-degree. So from here it says that it is 60-degree. Okay, so now we have 5 meter. Yes, we had a 5 meter pole. Then from 5 meter, from the top of the pole, we need to come down 1.3 meter because here the work is being need to be done. Okay, so what should be the length of ladder that should use, which when inclined at an angle of 60-degree to horizontal? So these are horizontal line. From here you have, okay, so it's forming a 60-degree. Okay, from here the ladder. So this is nothing but the ladder. Okay, so this ladder we need to find. So height of this ladder. Okay, my line is very bad. So let me use this line. Okay, so this need to be found. This need to be found. Okay, and what it says would enable her to reach the required position. Okay, so required position is this one, 1.3. Also, how far the foot of the pole should she place the foot of the ladder? Okay, so they are expecting even this distance where this foot should be placed. Okay, so this information it's asking. So let's name the points as A, B, okay, C, and D. Okay, so we have this 60. Okay, what else is given here? 1.3 from here, B is given. Okay, so we have the length of this. We have this side. Okay, we have a degree. Okay, so when you have one side and the other side is this one. Okay, so let's try to solve it. Okay, so let's get the value of BD. BD is nothing but BD will be this one from here. Okay, from here till here, because from here we need to find this is the triangle which are found, not from here. Okay, so BD is nothing but the complete, it's starting from top AD minus of AB. So if you remove BA, okay, BA. So total you have taken 5 meter. From there you have removed this 1.3 meter. Okay, so it will be 5 minus 1.3, which will be, one is removed, 4 from there, 7, it becomes 3.7. PD value we got it. Okay, so now what do we need to find? Okay, so we have this value, so we have an angle, so let's try to find the base here. Okay, so DC, so we know theta in the previous also we have done. So it is 60 degree. What is this? This is perpendicular and this is the base. Okay, perpendicular by base we know is tan. Okay, tan theta, and tan theta here. Okay, so it's nothing but here BD is perpendicular divided by DC or CD. Okay, DC. Okay, so tan we have the angle. What is the value of tan? Tan 60. We have the value of BD which is 3.7. Okay, so tan 60 we know root 3. Root 3 is equal to 3.7 divided by DC. So DC, let's bring it here. DC is equal to 3.7. This root 3 comes down. Okay, so further solving this, we have the value of root 3 given. Since it is given, so we can replace on the question here. So if you see here in the question, the value of root 3 is given as, we can substitute this value. Okay, DC is equal to 3.7 divided by 1.73. Okay, so further solving this, okay, so the decimal points is there, so the decimal if you can bring it here, so assume this whenever there is a decimal, so two digits are there, so you can assume this as 370 here, right? So two decimals gets cancelled, so this will be nothing but 370 divided by 173. Okay, so this goes how many times? So let's try to solve it here. 173. Okay, 370. How many times it goes? First one time, two times it goes, 36. Okay, two times it goes. So it becomes, okay, 6, so 3 becomes, okay, so 24.7. 0. So once it goes, then 173. So further it goes. So this we can take this value as, okay, approximately 2.1. Okay. So DC value we have it. Okay, students. So we got the value of this base. Okay, students. So we have got this value 2.1. Okay, and this is 53.7. Okay, so now the question is this ladder. So we need to find the length of this ladder. Okay, so which is nothing but the BC. Okay, BC. So we need to find the BC. Okay, we need to find BC, which is the length of the ladder. Length of ladder. How do we find? So here, if you see, this is our 90 degrees. So this becomes our hypotenuse. Okay, so we need to find the hypotenuse here. So the hypotenuse is there, and we can find, so how we can find? So we have our form rhyme, so we can use P, B, P, B, H, H. Okay, so now hypotenuse is coming into picture, so we can find either, we can either take sine or we can take cos. Okay, so let's take sine. So what is sine? Sine is nothing but sine, and okay, sine we have. So we can take sine. Yes. Okay, so we can take, okay, so BD. BD is for sine. One second. So we can utilize our sine. Sine degree is 60 degree. Okay, 60 degree, which is nothing but the perpendicular by hypotenuse. So what is perpendicular to this 60 degree is 3.7. Opposite to that is nothing but the perpendicular. Okay, so 3.7 we can put directly. Then hypotenuse remains same. Okay, so hypotenuse value. Okay, so we need to find the hypotenuse value, which is nothing but the length of the ladder. So let's write it as BC. Okay, so BC. So students, we know what is sine 60 from our table, trigonometric table. What it is, please comment it out. Then you can come back to this. Okay, so sine 60 is nothing but root 3 by 2. Correct? Okay, so then we have 3.7 divided by BC. Okay, so BC, let's bring the BC here. BC at the top, BC is equal to 3.7. So then this gets cross multiplied. So root 3 into 2. So for the solving, okay, so this becomes 3.7 into 2, 7, 7, 15, 4, 74, 7.4. So we have the root 3 value given in the question. So we can replace it by, okay, what is given here? 1.73. Okay, 1.73. 1.73. Okay, so here, so it becomes, so as I said, so point is there, so 2 decimal, so this becomes 740 divided by 173. Okay, so we have solved here for this 243, so 173, 740, how many times does it goes? Okay, so for, okay, 4 the 692. Okay, so remaining is what? Okay, it's 480, 0. Okay, so this becomes further 3, 4, 6. So further solving, I don't think we require. So we can take it as 4.2. Okay, so we can take it as 4.2. So the BC is nothing but the ladders. Okay, so ladders. Length of the ladder. So what is being asked here is BC. So BC is nothing but the length. So foot is required also for the foot of the pole. This we have found. She placed foot of the ladder would enable her to reach the required pole. Also, how far from the foot of the pole should they place the foot of the ladder? Okay, so we got the length of the ladder, okay, which is nothing but the BC, which is nothing but the BC. So we can mention it as length of the ladder. Length of the ladder is to be 4.2 meters. So remember the unit. So is it centimeters or meters? So that is very important. So this is what, okay, so it is in terms of meter. So students, so remember to put it in terms of meters. Okay, hope this is clear, students. So we have found the value by putting the question here. So it was saying there is an electric pole, okay, and that electric pole from 1.3 meter down we need to go where the actual work will happen. Okay, so then from the angle of horizontal. So horizontal we said from the view straight. So that is the horizontal from it, angle of elevation it is forming at the top. We need to have a ladder, okay, so which is at the 60 degree. So we need to find the height of the ladder. Okay, so the length of the ladder, not the height. Okay, so to find the length of the ladder, we have found what are the other sides. So once we found the other sides by using our sine formula, sine ratio, we found the value of the ladder. Hope this is clear, students. Okay, so two things which have been asked here. Okay, we have put it here. So here you need to remember. Okay, so both of these things you need to be highlighting. DC, you can mention it as what is DC. DC is also, this is nothing but the from the foot of the pole, okay, to the foot of the ladder. This is the distance between the, okay, so you can mention this as DC. Hope this is clear, students. So let's move to our next question. An observer 1.5 meter tall, okay, an observer is 1.5 meter tall, is 28.5 meter away from a chimney. Okay, there is a chimney. The angle of the elevation of the top of the chimney from her eyes is 45 degree. Okay, so that means top that person is looking, okay, elevation 45 degree. What is the height of the chimney? Okay, so there is a chimney. Okay, from the given data, we have a person who is one point. Let's take line. Okay, let's take line. So we have person who is 1.5 meter tall. Okay, so let's assume this is 1.5 meter. Okay, tall is 28.5 meter away from chimney. So from chimney there is a chimney. Okay, from which it is away. Okay, so from which it is away. So this is the distance. I can assume it as 28.5. Okay, here there is a chimney. Oops. So there is a chimney here. Okay, so let's assume this is chimney. Okay, so there is a chimney here. So the angle. So what is the next? The angle of the elevation of the top of the chimney from her eyes. Okay, so that person is here, over here. Okay, from her eyes. So from here, elevation means from here, the person is standing here. So which is almost 1.5 meter tall. From here, the angle of elevation. Elevation is at the top. So to the chimney, top of the chimney. So top of the chimney it says. So top of the chimney till here. Till here. This is the top of the chimney. It forms 45 degree. So 45 degree means this is the one. Okay, so let me take the pen. 45 degree. So this is 45 degree. And this is 1.5 meter. This is 28.5 till here. Okay, so this is the given. Okay, so 45 degree. We have collected all the information. 1.5, yes. 25.8, 28.5 meter away, yes. from the chimney. Okay, the angle of elevation, we have drawn the angle of elevation. Okay, from her eyes 45 degree. What is the height of the chimney? Okay, so we need to find the height of the chimney. So we need to find this height. Okay, we need to find the height of the chimney. Okay, so let's label this triangle. Okay, let's put it as starting point A, B, this is B, then we have C, then we have D. Oh, here also there is, we form a triangle, so make it as E. Okay, so E, A, B, C, D, E. Okay, H. Okay, so 45 degrees there. This data is not there, but base is there. This base is similar to what we have here, right? So this data is there. Okay, so what it is trying to find here, we have a degree here. Okay, this is what this is nothing but your perpendicular, right? Perpendicular, and adjacent to that is your base. Okay, let's use a pen. From triangle. Okay, so AED, from triangle AED. Okay, so we have from the triangle AED. So we have this data, we have this data. Okay, so we have the angle. So we need to find this. Okay, so that, okay, DE. Okay, D, because to find the height, we need to find height, which is nothing but DE plus EC. Okay, so we know EC. Okay, so we know EC. EC value is EC is equal to 1.5. So this is nothing but same distance here, right? And we know BC. BC is equal to 28.5. This is the data we have. Okay, so now from this triangle we need to find. So opposite to this is perpendicular. Okay, so perpendicular by base. What is perpend? One second. Perpendicular by base. What is perpendicular by base? Okay, P, V, P, B, H, H, H. Okay, so perpendicular by base is nothing but a tan. Okay, so let's take tan theta. Okay, so tan theta is nothing but the perpendicular by base, which we need to find. Okay, so what is here? Tan is nothing but here. Perpendicular is DE divided by base AE. Okay, and we know what is theta. Theta value is 45 degrees. So let's put tan 45 degree. Do we know the value of DE? No, we don't know the value of DE. Okay, do we know the value of AE? Yes, we know, which is 28.5. 28.5. Okay, so what is tan 45? Tan 45 is 1, which is equal to DE divided by 28.5. So this means DE is equal to 28.5. So we got DE. Okay, so we got DE value. Okay, DE value we got 28.5. So we need to find the height. Height is nothing but, so this we need to find, right? Height is nothing but DE plus EC. So DE we got it 28.5 plus EC. EC we have is 1.5. Okay, 28 half 29 30. So it becomes 30 meters. Okay, so the height of the chimney. Therefore, the height of the chimney is 30 meters. Hope this is clear, students. So we drew the diagram here based on the questions input. Okay, so then we saw what it forms here. So it is forming here the perpendicular by base. So what is perpendicular by base? We went to our rhyme and found out that it fits in as tan. So tan value we have put tan 45. Okay, and then perpendicular by base we got the value of this. Then we since we wanted the complete height, okay, so we added this uh, DE plus AB, which is equivalent to EC here. Okay, same height. Okay, hope this clear, students. So let's move to our next question. From a point on the ground, okay, there is a point on the ground. The angle of elevation of the top of a 10-meter tall building, 10-meter tall building is 30 degree. Okay, so it forms a 30-degree elevation. Okay, a flag is hosted at top of the building. A flag is hosted at the top of the building, and the angle of elevation of the top of the flag staff. Okay, from P is 45 degree. Okay, so there are two angles here. Okay, find the length of the flag stag and the distance of the building from the point P. Okay. Okay, so from point P on the ground, so there is a ground elevation of the top 10-meter tall building is 30 degrees. So there is a building here. Okay, let's take a line. So there is a building here, okay, which is of 10-meter tall. Okay, so let's assume this is 10-meter tall. 10-meter tall. Okay, so 10-meter tall. This is 10-meter tall. Okay, from a point on the ground. So from the ground, on the ground, the angle of elevation of the top. So it forms from somewhere in the ground that angle of elevation. Okay, so from here, if I form, it is forming an angle. So this is the ground. Okay, this is the ground. So basement for this, it is forming a 30 degree. So 30 degree means here we need to draw a horizontal line. So here it forms a 30 degree. 30 degree. Okay, so this is 10 meters. So 10 meters. Okay, so this is 10 meters. Okay, this is the height of the building. Point P. So this is our point P. You have a 10-meter tall building. You have 30 degree. Okay, building. A flag is hosted. Okay, so a flag is hosted at the top of the building. So this is the building end, right? So on top of that, there is a flag hosted. There is a flag hosted at top of the building, and the angle of elevation and the angle of elevation of the top of the flagstaff from P is 45 degree. Okay, from this P it makes a 45 degree. Okay, so from this P it makes a 45 degree. 45 degree. Okay, find the length of the flagstaff. Okay, so we need to find the length of this. Okay, we need to find the length of it. Okay, we need to find length. Let's say L. Okay, till here the building is there. Above that building there is a flag hosted. So flag tag. Okay, this distance we need to find. What is the distance of the building? Okay, length of the flagstaff and the two things it's asking, distance and the length of the flagstaff. Distance of what? From distance of the building from the point P. Okay, so this is the building, right? So it's asking you this as well. Okay, so let's start naming it as P, Q, R. This is one point. P, Q, R. Let's name it as S. Okay, hope this diagram is clear, student. Okay, so if not, just reverse back how we went ahead. That will help you to draw this diagram. Okay, so I'll tell at the end of the question solved. Okay, so how we got this again. So let's go with our values, what it is. Okay, so 30 degree. So we have here 10. What else is there? So two triangles we have. Okay, so if we form here, if we find the QP, yes, we can find the QP by the trigonometric ratios. So we can find here So 30 degree, what is it? Opposite to is perpendicular. Perpendicular by base. Okay, so perpendicular by base. What is that perpendicular by base? Okay, so P, B, P, B, H, H. Perpendicular by base, it forms here. So which is nothing but the tan. Okay, so in triangle, in triangle PQR. Okay, PQR. In triangle PQR. Okay, from this triangle. So we saw this, with this we'll get this value. So tan theta. So we will take tan theta. Why we take tan theta? We have seen it is perpendicular by base. What is perpendicular to 30 degree is value is 10 here. Okay, this is perpendicular. QR is perpendicular. Okay, to this angle QR. Okay, perpendicular. Then we have the base. What is base? Base we don't have. QP. Okay, so tan theta, theta is 30 degree, tan 30 degree, 10 by QP. So what is the value of tan 30, students? From the table we know tan 30 is nothing but 1 by root 3. Okay, it's just 10 by QP base. So QP comes here. Okay, it gets multiplied 10 into root 3. Hope this clear, students. How did we find the QP value? Okay, so in the question we have been given as root 3 value as 1.732. So let's put this value here. QP is equal to 10 into 1.732. So 10 multiplied, this goes here, so it will become 17.32. So this will be the value of our QP. So we got the value of QP. Okay, so we got the value of QP 17.32. So now we need to find this distance, right? So here distance we need to find the L. Okay, this L we need to find. To find this L we need to form the, okay, so we can find it assuming this is the length. L plus 10 is the, okay, so length we have 45 degree here. Okay, and we have QP. So we have QP. So let's, so what is there? So this is nothing but 45 degree we have. The new, this one angle is 45 degree. Okay, so this is from here till here. This is nothing but the 45 degree. So perpendicular by base. So we can take similar perpendicular by base. We saw it is tan. So we have tan. So what is the angle here? Tan 45 degree perpendicular. What is perpendicular? Okay, perpendicular is nothing but SQ, right? This from starting from here, SQ. This is the perpendicular, right? SQ divided by QP. So SQ divided by QP. We know what is tan 45. Tan 45 is nothing but 1. SQ is nothing but L plus 10. L plus 10, right? This, the entire length of this is 10 we have, then plus length of the flag stack. Okay, then we have QP. QP we found it 17.32. Okay, so 17 cross multiply 17.32 is equal to, sorry, 17.32 is equal to L plus 10. Okay, so let's take L left hand side. L is equal to, L remains here, 17.32. This 10 goes left side, it becomes minus 10. So L becomes 7.32. Okay, so this is what is the value of the flag stack. So L value is 7.32. Hope this clear, students. Hope this clear. So here don't get confused. So found, as I've said, so what it says is from a point of ground, the angle of elevation of the top of a 10-meter tall building. So draw a 10-meter tall building. Okay. Okay. From there is a viewpoint of 30 degree elevation. Elevation means from the top. Okay. So to the point P, which is down. Okay. Point P, ground. It says on the ground, right? So from this we can say the point P is on the ground. So with that, we drew an angle of elevation 30 degree. So first angle we got it, which is nothing but this one. Okay, so let's use this. So this is the first one. Oh my goodness. So this is the angle we got it first. Okay, which is highlighted. Okay, then it said the building and the angle of elevation. A flag is hosted. So after that, a flag is hosted on top of this. Okay, a flag is hosted on top of this. So which is being highlighted here. So at top of the building and the angle of elevation of the top of the flagstaff from P. So from P, it's making another angle. Okay, because the distance has increased here. So another angle. So as you can see, it is 45 degree. So it increases the angle increase 45 degree. So they're asking to find the length of this new whatever this hosted flag stack. Okay, and we were not aware of this base. Okay, so we use the trigonometric ratio. Here we found perpendicular by base. So angle is given. So we substitute the angles value in the trigonometric ratio. Okay, and we got the value of QP. So using this QP value, we found the value of the length by substituting again with the trigonometric ratios. Hope this clear, students. So if not, please go back and try to start from the beginning and draw the diagram. So that will help to figure it out much better. Okay, hope this clear. Let's move to our next question, students. A shadow of a tower standing on a level ground. Okay, so there is a level ground found to be 40-meter longer. When the sun's altitude is 30 degree, then what is it? 60 degree. Well, and then when it is 60 degree. Okay, so when it is going to be 60 degree, find the height of the tower. Okay, so a shadow of the tower standing on a level ground. Let's read the question here. Okay, from this, the shadow of a tower standing on a level ground is found to be 40-meter longer. 40-meter longer when the sun's altitude is 30 degree than when it is 60 degree. Okay, than when it is 60 degree. So this is nothing but then. So 40 meters. It was 40 meters when it is 60 degrees. So then it says here, find the height of the tower. So let's assume there is a tower. Okay, so let's take a line. So let's assume there is a tower. Okay, so tower is there, and due to the sun. Okay, okay, this is okay. So due to the sun, so here assume there is a sun. Okay, this is not. So I need to use this. So there is a sun. Okay, so sun is there. So due to the sun, it's forming a shadow. So shadow is forming towards this altitude. Okay, so down you will see the shadow. So there are two shadows here, if I understand. So from this question, it says that two shadows is there. Okay, so let's take. Okay, so one shadow is here. Okay, and there is another shadow which is taking, making a another degree. Okay, so let's assume this. Okay, so found to be 40-meter longer when the sun's altitude is 30 degree and one. So from this we saw shadow of a tower. So two shadows we found. Okay, so now since we have, let's make a horizontal line to make it correct. Okay, so let's make it. Okay, so we have a tower. Okay, and you have something called, okay, the shadow from the sun. Okay, and which is forming 60 degree and 30 degree. Why this is 60 degree and why this is 30 degree? As you can go nearby, as you go nearby, you can see that this is nothing but 90 degree, right? So we have a 30 degree and 60 degree. So up as you are approaching further, the degree increases. So the as you're going away, the degree reduces. So we have a 60 degree here, okay, and then it reduces, so 30 degree here. So let's take, so students, clear why we took 30 degree here, 60 degree here? So always remember this way, okay? So as you are nearing by to the perpendicular, it is 90 degree, right? So as you will be going away from it, the degree keeps reducing, okay? So that's why we have 2 degrees here, 30 degree, 60 degree. So from the sunlight shadow, it's making two angles here, 60 degree and 30 degree. And it says that ground is found, okay, on the ground. So this we have made a ground is nothing but the horizontal line, okay? This is nothing but the line of sight. This two red and orange makes line of sight, okay? And this is nothing but the horizontal line. Okay, so it says that found to be 40-meter longer when the sun's altitude is 30 degree than when it is 60 degrees. So it says that when it is 60 degree, ground is found to be 40-meter longer when the sun's altitude is 30 degree than when it was 60 degree. Okay, so it says that 40-meter longer. Okay, so earlier it was 40-meter. So with this it was 40-meter. Okay, this was 40-meter, then this is longer, so this is saying this is longer, right? Definitely it is. As you can see, this length will become longer, so this is nothing but, okay, 40 plus, we don't know how long it is, so but at least from this it is 40-meter plus x. Okay, so this is what it's trying to say here. So please read it here. Is found to be 40-meter longer when the sun's altitude is 30 degree. So it's saying longer, but when it comes to 30 degree, it is longer. But how much? That value we don't know. Okay. Then when it was 60 degree. So when it was 60 degree, right? So this was 40. Okay. It is saying clearly as a longer. So longer with what? With that value we don't know. So that's why I put a X. Okay. So now we have the triangles. So by solving these triangles, we will get the by trigonometric ratios, we'll get the value, okay, of this x. We need to find the height of the tower. Okay, we need to find the height of the tower. Okay, so we need to find, okay, let me take a line better. Okay, we need to find the height of the tower. So let's name it as A, B, C. Okay, so there are two triangles here, okay, with the red one, okay, it forms another one with the orange. Okay, so there are two triangles which we have. Okay, so what do we need to find here? Okay, so if we take the smaller, we have the base here value. Okay, so base is there. Okay, so we need to find the perpendicular. 60 degrees perpendicular is this one. Then you have a base. Okay, fine. So we can go with that. Okay, so we have what is the value of this? So we can find, yeah, perpendicular by base is nothing but tan. So from here, P, B, P, B, H, H. Okay, perpendicular with base, we can take this is tan. Okay, so tan theta. So tan theta of, let's take the 60 degree, any of the angle we can take. So let's take the 60 degree here. Okay, so tan theta, what is the perpendicular to this is H. We don't have the value H, let's put it. Then base is nothing but this. Okay, its value is X. Okay, so we have this, and we have the angle tan 60 degree by H X. So what is tan 60? Tan 60, you know, it is nothing but root 3 H by X. Okay, So till here we have root 3 h by x. Okay, so here we have the value. So now let's find with this angle what do we get it. Okay, so still the same thing, only thing is here this distance changes here, AC so tan theta, here theta value is 30 degree, 30, and perpendicular remains same height, sorry, height divided by the base is nothing but AC, which is 40 plus x. This is the one, 40 plus x. Okay, so what is tan 30? It's 1 by root 3. Okay, this is h divided by 40 plus x. Okay, so let's bring reverse cross multiply. 40 plus x is equal to h root 3. Okay, so then x is there. So what is the value of x here? X is equal to root 3h minus 40. Okay, so can we replace this in any of this form? Okay, here we can replace. So h value we have, either we can put h value. So find the height of the tower. So we can find the height of the tower here. Okay, so let's replace the value of x here in many of we need to find height, right? So let's put this as h is equal to root 3 into x. So from this, okay, h we got root 3 into x. So let's put the value of x here, root 3 into x. X we got it from here, root 3 into h minus of 40. Okay, root 3 into root 3 becomes 3h minus root 3 into 40. Okay, okay, so you have h here. Okay, so let's reverse, let's bring this root 3 here, root 3 into 40 here. Okay, then 3h we have, then this h, let's bring it towards, it becomes minus h. Okay, so this becomes 2h and 40 root 3. Okay, so so root 3 into 40 divided by 2 is equal to h, 220. Okay, so it becomes 20 root 3. It can be written as root 320 or 20 root 3 into h. Okay, so this is the value of the height of the tower. This is the height of the tower. Okay, so hope this clear, students. So two things to be remembered here. One thing is the degree. So as the degree approaches near to the perpendicular, it increases. Okay, as it is away, it decreases. So that's why we took 30, 60. Simple formula remembering. Okay, this way you can put if 2 degrees are there to be found. Okay, and the details. So we use the uh, trigonometric ratio. We found it is uh, coming to tan. So then we replace the degree value, okay, theta value, tan theta. Here we got 30 and 60. So after substituting this, we got the value of height, h. So all the problems are related to this. So just need to replace the values in a proper format, okay? So then things will get sorted out. Hope this is clear, students. So try once or twice this sort of questions, you will get to know about it, okay? So look at multiple times, then you'll get the more clarity on this. So I'm not going into making it more complex, just trying to see this is what just you need to remember as if you're working in the exam. Okay. So telling more of the concept will get you more into problematic areas. So remembering this basic concept, what is required, how do you solve it? This is how you need to go in an approach. Okay. So that will help you move forward. Hope this is clear, students. So let's move to our next question. Okay, students. So let's read our question here. the angles of depression of top. So depression means down. Okay, the top the of the top and the bottom of an 8-meter tall building. So you have a 8-meter tall building from the top of a multi-storied building are 30-degree and 40-degree. Okay, so there is a building and there is a multi-storied building. Okay, that means multiple floors are there, multi-storied building. Okay, 30-degree and 40-degree. So okay, so there are 2 degrees which is being formed. Okay, fine. Respectively, find the height of the multi-storied building and the distance between the two buildings. Okay, so now the thing is, let's try to put the question in a diagram. Okay, so always draw the diagram, students, whether it is asked or not, so that will be helpful. So the angles of a depression, so that of the top of the bottom of an 8-meter tall building from the top of a multi-storied building are, okay, so 8-meter tall building is there and the bottom of a 8-meter tall building. So there is an 8-meter tall building. Okay, 8-meter tall building, fine. Okay, there is an 8-meter tall building top of an 8-meter tall building from a top of the multi-storied. So there is a multi-storied building whose top. Okay, there is a multi-storied building. So let's assume this is a bigger. Okay, no, much bigger. So there is a multi-storied building. Why is this? There is a multi-storied building. Okay, so let's assume this is there. Two buildings. So one building it says 8-meter and there is a multi-storied building. Okay, so from the top, so top of it. Okay, so it says top of the multi-storied building. It's making a 30-degree and 40-degree. The angle of depression. So from here it needs to see. Okay, so from top of this building, it's making an angle of depression here. One is top. Okay, so this is the building, second building. Okay, multi-storied building to top. It says that from the top tall building from the top of the multi-storied building at 30 and 40-degree. So depression. So two angles, depression angles, the angles of depression of top and bottom of an 8-meter building. So there is an 8-meter building, okay, building whose top and bottom from the top of a multi-storied building are 30-degree. So there is a two angles it makes from the top of a multi-story building. So you have a multi-story building, you have a 8-meter building. Okay, so it makes it depression of the top and the bottom. So of whom? Of the 8-meter tall building. So top it makes one depression angle from and bottom it makes another depression angle which are 30 and 40-degree. Okay, so from this top. So this means, okay, so okay, so when it makes here, so top, this is the top, right? So top, let's connect it here, let's connect it here. So here it says from the top of this it makes to the top of that 8-meter building as 30-degree. Okay, so it makes a 30-degree, and then again it says from this top to the bottom it makes 45-degree. Okay, from here this top it makes to the bottom of the building 45-degree. Okay, so let's connect, this is our horizontal line. So here it says this makes a 45-degree. Sorry, it's 40, 45 or 40. Okay, so in the question it should be 45 degrees. Okay, so let's put it, no problem. So we can change it. Either we can change it here 40-degree, 45, let's put it, because for the trigonometric ratios we use the standard one. So fine. So let's change it here. So we have the 45-degree here. So this distance is given as, this building is tall. How tall it is? 8 meters. So this is 8 meters. So this is 8 meters. And similarly, this also will be 8 meters, right? Okay, and the total, find the height of the multi-storied building and the distance between the two buildings. Okay, so you have two buildings. So let's name it as A building. This is B building. Okay, and then you have C, this particular T. Let's name it as E. Okay, so this distance we need to find. Oh, this is not good. So we need to find this distance. So this distance we need to find, and we know this distance is nothing but 8 from here. Okay, and this distance we need to find. Okay, fine. So we have these details. Have we covered all the data from the question? Yes. Okay. So let's try to resolve it with our trigonometric ratios here. Okay. Okay. From triangle, you have ECD. Okay. You have ECD. So this is the angle 30 degrees. Then you have opposite, which is perpendicular to the base. So what is this? It is nothing but ED. Sorry, before that, it is perpendicular by base, which is nothing but tan. Okay, tan theta, which is nothing but ED divided by CD. Okay, so tan degrees, 30 degrees here. Tan 30 is equal to ED divided by CD. So we know what is the value of tan 30 from a trigonometric table. It is nothing but 1 by root 3 equal to ED divided by CD. Okay, so let's cross multiply. CD is equal to root 3 into ED. Okay, so ED. Fine. So till we have, so we have another angle. So from that angle, let's see what we can get it. Okay, so let's take some space here. From triangle A, E, B. So we have perpendicular, same perpendicular by base, which is tan. So here we know tan degree is 45. So tan 45 is equal to, what is it? It is nothing but complete height. Height divided by, okay, so height is nothing but, okay, so complete height here we have, which is nothing but, okay, height divided by AB. Tan 45 is 1. Okay, height is there. Then we have the value of, okay, so AB is nothing but the value of CD. So can the AB is equal to AB is equal to CD? Yes, same distance we have. So this can be corrected. So CD. So we have the value of AB. Let's replace it with this value. AB is equal to CD. Since AB is equal to CD. So we are putting root 3 into D. Okay. So root 3 into ED is equal to H. Okay, so from here we know what is h. H is nothing but h is equal to ed plus db. Okay, and we know the value of db. db is equal to 8. Let's try to substitute it here. Okay, so root 3 ed is equal to h is nothing but ed plus 8. So we have replaced the value of db here. Okay, so bring the root 3 ed minus ed towards left side is to 8. Okay, so then common, let's take ed outside. Ed, okay, this becomes root 3 minus 1 is equal to 8. Okay, so what is ed here? Okay, so ed, okay, so ed is the one which we need to find. Okay, so here we need to have this format, right? So ed is equal to 8 divided by root 3 minus 1. Let's rationalize it. It's in the form of a, okay, so let's rationalize. What we do, we multiply and divide with the numerator with the opposite sign. Plus minus is there, plus it becomes, okay, root 3 plus 1. Okay, so 8 into root 3, okay, plus 1 plus 1 divided by root 3 a minus b into a plus b. So it becomes, so a minus b into a plus b. Here root 3 minus 1 into root 3 plus 1. Okay, so we can use the formula a square minus b square. Okay, so 8 root 3 plus 1 divided by a square. A is root 3 here. A is equal to root 3 and b is 1. Okay, root 3 whole square becomes 3. Okay, minus of b square is 1, whole square is 1. Okay, further solving, 8 root 3 plus 1 divided by 3 minus 1 is 2. 2 goes 4 times. So this will be 4 into root 3 plus 1. Okay, so this is the value of ed. Okay, so from this we need to find the, okay, so height. So this is what we need to find, the height h. Okay, which is nothing but ed plus db. So db value we have 8. So let's try to put it here, solving here. Okay, so the value of h is nothing but ed. So ed value we have it as 4 into root 3 plus 1. Okay, plus of this db value is 8. Okay, how did we get the value of db? Db is given here. Okay, so CAC is equivalent to dB, so hence we took this value. Okay, so let's solve it further. 4 root 3 plus 4 plus 8. 4 root 3, 4 plus 8. So either we can 12. Okay, so 12 is there. Okay, so we can take 4 common. Root 3 plus 4 3 is Okay, so height. So this is the height of the multi-storied building. So this is the height of the multi-story building, and this is the distance. So this distance we form EB. AB is nothing but equal to CD here, right? So we form this distance. This is the value. Okay, so you can highlight it here. So we form the distance between the two buildings and also the multi-storied building height we found it. Okay, so a little bit length here, but I think if we start reading this question and try to practice what we have gone through step by step, that will be helpful. So remember, when you have multi triangles, so you can sort it one by using the trigonometric ratios. You get the value and try to get the another unknown value by the first triangle which you have resolved. Okay. Okay, students, let's move to the next question. Okay, students, so what it says is, from a point on bridge across a river, the angles of depression of the banks on opposite sides of the river are 30 and 45 degree respectively. If the bridge is at height of 3 meters from the banks, find the width of the river. Okay, so we need to find the width of the river. So you are at a bridge. Okay, so you are at a bridge. Okay, so you're standing at a bridge, so looking down, so that means depression angle. So depression angle of the banks on opposite sides, so opposite sides, so one side. Okay, so assume that you're standing here, this is the bridge. Okay, so you have a river, so assume let's have a river here. Okay, starting from here. Okay, let's take a line, let's take a line here. Okay, so this is our river, assume this is a river, and top we are standing. Okay, from one side we are seeing that it's forming one angle. Okay, and from the other side it's forming another angle. Okay, so nothing but the depression angle. It says depression is nothing but down, so looking down. Okay, so usually if you see this, so one thing which if you see that, you will observe that I'm directly writing this angle. So whenever it says an angle of depression, right, so you need to form an horizontal line. Okay, these are horizontal line, and this is a line, sight of line. Okay, line of sight, you can say line of sight or sight of line. So this red which I'm showing, okay, and the black which is showing is being said as the horizontal line. Okay, so here it forms a angle. So depression is nothing but this angle it's going to form. Okay, so this is going to form an angle. Okay, this is going to form an angle. So here it says a 30 degree. Okay, one side, another side says is 45 degree. Okay, 45 degree. So if you straight away, if you can just remember in the, whenever it says as angle of depression, you can assume the opposite side. So based on the alternate interior angles, okay, based on that you can assume this has 30 degrees. Okay, and this has 45 degrees. Okay, and remember that we have a division here. Okay, so right angle triangle we are making. So it says that the height of the height is nothing but 3 meters. Okay, so this data is given 3 meters. Okay, so you can straight away, when it says as angle of depression, the alternate you can put it. Okay, based on that angle of intersection. Okay, you can form the angle based on that. 30 degree here if you have, you can put 30 degree here. 45 degree here you have, you can put the 45 degree based on the alternate interior angles. Okay, so now we have formed a two triangle here, so it's basically asking you to find the this distance. Okay, it's asking you the distance, reverse distance. Okay, So how you can find? So this is one angle, one point. You're looking one side, this side, one side, another right hand side you're looking. Okay. So opposite sides you're looking. Two opposite sides. Standing here, you're looking at the two opposite sides. Two opposite sides. So it's forming the two angles. So you know the distance. So angles, you know. So you can use one of the angles. So let's start naming this as A. Starting your point A, then one B. Okay, then you have this one C, then you have D. Okay, so let's find from our angle in triangle, in triangle ABC, in triangle ABC. Okay, so what is ABC? 30 degrees. So perpendicular by base, perpendicular by base is nothing but tan. Okay, tan. So tan theta. So here what is the angle we have? Tan 30 is equal to, tan 30 is equal to, what is it? So the perpendicular is given, value is 3. The base value is not there, we need to find it, BC. Okay, so what is tan 30? Tan 30 we know it is nothing but 1 by root 3. Okay, is equal to 3 by BC. Okay, cross multiplying, BC is equal to 3 into root 3. Okay, so we got till here BC, till we here we need to find CD. So similarly we can find from this triangle. Okay, in triangle, in triangle ADC. Okay, so this is nothing but perpendicular, perpendicular to base, so tan. So we can directly put tan 45 is equal to, perpendicular is given as 3 divided by DC. Okay, DC or CD. Okay, so tan 45 you know it is 1 is equal to 3 divided by DC. Okay, so DC is equal to 3. So we have the value of DC. Okay, which is equal to 3. So what do we need to find? The length of this river, which is nothing but, length is nothing but BC plus CD. Okay, so we have the value of BC as 3 root 3 plus CD. CD or DC is to the same, so it is 3. So this is the value. So if we take 3 common, it becomes root 3 plus 1. Okay, so this is the length of the river, length of the river. So this is our answer. So hope this is clear, students. So this was, so one thing to be remember is whenever there is an angle of depression is given, so just use this theorem, okay, or angle of intersection or alternate interior angles. So that angles, whatever you decide. So let me just put it here, something like this. So you assume this, you have, okay, let me take lines here. So you have two lines here, and there is an intersection, okay, intersection, okay. So here, whatever this angle you have here, right? Whatever the angle you have, whatever the angle you have, theta, is nothing but this angle. Okay, that's how you can interpret. So I hope this is clear. So using this, or simply whenever you see in the angle of depression, you can put the angle opposite to here. Okay, so instead of converting this, okay, so you can form, okay, drawing this diagram will help you out. So by this you can put the value, and solving this as a triangle, one-sided, using the trigonometric ratios, it's going to solve. So most of the questions you need to remember in this way. Okay, so try to do 2-3 times this sort of pattern of questions, and whenever this comes, so you don't need to remember most of the, whenever it says angle of elevation, angle of elevation remains same, but when, especially when it comes to angle of depression, this particular you can apply. Okay, alternate interior angles, so you can apply directly like how I've done in this and the previous question. Hope this is clear, student. With this, we have come to an end of this examples of the this particular chapter 9, okay, which is an extension of the chapter 8, some of the applications of trigonometry. Hope this is clear. So, thing what you need to remember in this particular chapter is about the trigonometric ratios, okay, trigonometric values, the table, okay. The ratios is nothing but if you want to find, usually if you see we have used the tan. So once you especially when it comes with the hypotenuse in the ratio, that time you can use the sine and cos, otherwise it's always tan, okay. So remembering tan values will be helpful, starting from tan 30, 45, tan 60. So if you see, this is the mostly being used, okay. So if you think this is more to by heart or remember, so this is where you can remember it, okay. Hope this is helpful, students. So let's move. So for this particular session, we'll wrap it up here, and for the next session, see you then. Take care. Bye bye.